Hello, this is chapter 7.1. We're going to graph exponential functions. Exponential functions have two graphs. There's a growth factor function and there's a decay factor where the graph decreases and the growth factor is when the graph increases. So they're similar, but one goes up and one goes down. So we'll look at the two. Let's look at our vocabulary here. So what is an exponential function? It's a function where the base is a constant and the exponent is the independent variable. For example, y equals 10 to the x. So if we look at y equals 10 to the x, the parent function is going to be f of x equal b to the x. Okay, so our base is here as a constant, and then our independent variable is in the power, the exponent. So let's look at the key concept box here. Okay, and an exponential growth is just a function in the form of f of x equal b to the x, where b is greater than 1. So this constant here, this base, is greater than 1. So remember we talked about exponents, exponent being it has two parts, a base and a power. So the base is going to be a constant that's greater than 1, and the power is going to be x, the variable. Okay, then we're going to have an asymptote. An asymptote is simply a line that the graph approaches. Okay, so let's look at this parent function. Let's look at this key concept box. So f of x is b raised to the x is your equation, and b is greater than 1. When it happens, the type of graph is continuous, it's 1 to 1, and you see it's increasing. As x approaches positive infinity, so does y. The domain is going to be all real numbers, and the range is going to be y greater than 0 because it's the x-axis of the parent function. The asymptote is the x-axis, which is represented by the equation y equals 0. And they tell you here x-axis, which you would say y equals 0. Range, so it means as x approaches negative infinity, y approaches 0, but never touches 0. It'll never be 0, never cross this graph. It'll just be small, have like infinite number of decimal places. Okay, and the intercept is going to be at 0, 1. Now there's three things that 3 points you need to know of the parent function. It's always going to have the values of -1. If we look at the key concept box, -1, comma 1 over b, 0, comma 1, and 1, comma b. You need to memorize this. This is the same for both the growth and the decay. Right now we're doing the exponential function, growth function. Okay, b is not the b that we're used to seeing for transformations. B is going to be this base of the exponent. So for instance, this b would be 10. So these variables would be -1. These coordinates would be -1, comma 1 over 10, 0, comma 1, and 1, comma 10. So you could plot those three and connect the dots and you would see the graph. Okay? So let's look at example 1. It says graph y equals 3 to the x to state the domain and range. So we said we're going to have -1, comma 1 over b. So b is going to be 3. And then 0, comma 1, and 1, comma 3. So if we went to go graph this, that's 0, comma 1, 2, 3, 1. So this is 1, comma 3. -1, comma 1/3, about right here. And we connect the dots because we know what the graph looks like. And it's going to approach this. So the domain is still going to be all reals, and the range is going to be y greater than 0. And the asymptote, which they don't ask for, I'm going to ask for it, so you need to know this, is going to be y equals 0. It's the x-axis. Okay? And notice that the parent function is y, or f of x, equal b to the x. So you have really infinite number of parent functions. This could be 3, this could be 4, this could be 5. It's still a parent function. There's no transformations going on. The only difference is as this b increases, the y gets closer to the y-axis. So it moves this direction as b increases. Okay, so pause it, do guided practice 1, and then we'll pick up on example 2. Now example 2 is going to be your transformation. So you have f of x equal a times b raised to the x minus h plus k. All right, so A tells us if there's a vertical reflection or vertical stretch or compression. Just like any other one. So when A is negative, you have a reflection over the x-axis because it's a vertical. If A is greater than 1, the absolute value, then you have a stretch. If the absolute value of A is less than 1 and greater than 0, then you have a vertical compression. H tells you does it shift right or left, and K tells you does it shift up or down. Just like anything else, you see it's x minus h, so it's the opposite. So let's look at example 2. It says graph and state the domain and range. Y equals 2x, y equals 2 to the x plus 1. So our h is 0, our k is 1, and our a is 1. And our base, I'm going to make it capital B, so you know we're talking about the base, is 2. So it's greater than 1. So it's going to use negative 1 comma 1 over 2, so 1/2, 0 comma 1, and 1 comma 2. So let's go plot those points. So we have 0 comma 1, and we have 1 comma 2, and negative 1 comma 1/2. So all this did was do what? Oh, so that's the parent function. However, what happened? HK is now what? 0 comma 1. So you have to do the transformations. So this is the parent function, x comma y, and we know we had x plus 0, or just simply x, and then we had 1 times y and y plus 1. So we're in x doesn't change, so negative 1, 0, 1, plus 1, so 1/2, so this is 3/2, or 3 over 2. And 1 plus 1 is 2, and 2 plus 1 is 3. So our new graph is going to be negative 1 comma 1.5, 0 comma 2, and 1 comma 3. So you can see that our graph did what? It shifted up by 1 unit. And that was it. There was no vertical compression or anything else that went along with it. Any other dilations or reflections. Okay, so let's look at example B. This one's a little more trickier. So y equals, it looks like negative 1/2 times 5 to the x minus 2. So here we have A is negative 1/2. H is 2, and K is 0. So we go and take our parent function, x comma y. So we said we have negative 1, 1 over b, so 1/5, 0, 1, 1 comma b, which is 5. And I'm going to put here b equals 5. That's how we get this. Now we know that this affects the x, and these affect the y. Yes? So I'm going to do x plus 2, and then I'm going to do negative 1/2 y plus 0 or just negative 1/2 y. So I'm going to put this into this formula. So that's going to be 1. 0 plus 2 is 2. 1 plus 2 is 3. Then we're going to put 1/5 into here. So we're going to get negative 1/10, negative 1/2, and negative 5/2, because 5 times negative 1/2 is negative 5/2. That's our new graph. So we're going to go, x is going to be 1, 2, 3, and y's are going to be 1, 2, because this is 2.5, 3. Okay, so 1, comma, negative 1/10. So somewhere right here. And then 2, comma, negative 1/2. So it's going to be right here. And then 3, comma, negative 2.5, which is about right here. And we know that it reflects, so we know our graph is going to do this, correct? So we know that the asymptote is now going to be what? Still y equals 0, because it didn't shift up or down. And our domain is going to be still all reals, and our range is going to be y less than 0 now instead of greater than 0. Okay? All right, pause it, do guided practice A and B. Okay, now, what we need to know is there's an equation, and we use this in finance, to find an amount A of t equals A times 1 plus R raised to the t power. So A of t is an amount of t time periods, and A is an initial amount, and R is the rate of increase. And we call the 1 plus R part of it the growth factor, because it's a plus, it's a growth factor. So if we're trying to find how something increased over a certain amount of period of time, this is used a lot in finance and real world, so we're not going to do that example 3. We're going to go ahead and skip it, but basically we would plug in the values for this, know what they mean. We will be looking at them a little bit later. Let's look at the key concept box now. Now we're looking at decay factors, all right? So this was growth because B was greater than 1. Now that we have B is between 0 and 1, means it's a proper fraction is what it's saying. Now we have a decay. So you want to find out how much something is decaying away. Use it in science. You could use it in finance maybe, but mostly in science you will see this decay factor. Now the domain is still all real numbers. The range is still y greater than 0, and the asymptote is still y equals 0, and the intercept is still 0, 1. And if you notice, we have the same points, negative 1, 1 over b, 0, 1, and 1 over b. So let's look at the parent function. This is still another parent function, but it's a decay because b is a fraction between 0, a proper fraction. So if we want to graph that function, y equals 1/3 to the x, I can say it's negative 1, 1 over b is 3, 0, 1, and then 1, b, 1/3. Let's go and graph that and see what it looks like. So 0, 1, negative 1, 3, and then 1, 1/3. So do you see the graph? It just goes the other way. All right, so something is exponentially decaying. You can make a table with a bunch of numbers, but as long as you give me these 3 points, I'm good. All right, so the domain is still all real numbers. The range is still y greater than 0, and the asymptote is y equals 0. All right, so pause it, or let's look at B. Actually, B is a transformation. So it's y equals 2 times 1/4 x plus 2 minus 3. So let's look at the transformation. So a is 2, h is negative 2, k is negative 3. What is my b? Remember I said I'm making it capital at my base. It's 1/4. Okay, so remember it's negative 1 comma 1 over b, 0 comma 1, and 1 comma b. So our points are going to be negative 1 comma 1 over 1/4 is 4, 0 comma 1, 1 comma 1/4. Okay, so that's our parent function. But what transformations are taking place? So we have x minus 2, comma 2y minus 3, right? Because this is always times y, and this is plus y. All right, so we're going to take these coordinates, negative 1, put it in here, we get negative 3. Put 0, we get negative 2. You put 1, and you get negative 1. So negative 3, negative 2. And then you put 4 into this equation, you get 5. You put 1 into this equation, you get negative 1. You put 1/4, and you get negative 5/2. Okay, so now we can graph this. These are our points, 1, 2, 3, 1, 2, 3, 4, 5. Oops, negative 3, sorry. Negative 2, negative 1. And then negative 1, negative 2.5. So it's about right here. Okay, it's still the same shape. So our domain is going to be still all real numbers. Let's look at what is our asymptote. Okay, so we look at k. So it was 0, but it went down 3, so our asymptote is y equals negative 3. And what is our range? It's going to be y greater than negative 3. So it's going to approach negative 3, but never touch negative 3. All right, so pause it or stop it and do guided practice 4A and 4B.